Well, hello and welcome to episode 3 of Bite Size InfoSec. So today I'm actually in Melbourne. Yeah, over here for the AusTech conference, which is happening this weekend. I think there's some training and workshops tomorrow as well. But I'm over here a day or so early. What I got for lunch today was went to Vacation, which is a place that does really, really nice toasted sandwiches. Got the Meat Smith here, which is a Wagyu pastrami. So if you're in Melbourne, and you're looking for a toasted sandwich, Vacation, definitely the one that I would recommend. Trying to make sure it's all in shot for you. So today, I think what we'd talk about today is mic drop. This is a Microsoft vulnerability. Surprise, surprise! It's in sort of the Samba code base. Sort of the network sharing remote code. It can give you remote code execution on a box, sort of like all these Samba-ish things. You know, Microsoft has been trying to secure Samba with the signing and encryption and all that over the years. But this Samba related sort of section of code seems to be that sort of pen test in, pen test out. It's the way to get remote code access and escalate to root or get onto the server that runs the production database or web app, and so you can basically get all the company's crown jewels by getting their main database, be it their SharePoint, be it their CRM database or whatnot. So, and how this one works is mic drop. Can't remember what mic stands for. It's an acronym, MIC. But basically, at the top of these messages, there is some signing and attestation, which sort of allows the sort of verification of the message. And what happens here is that your domain controller might have all the boxes ticked, but you might have an older server that doesn't support some of these newer features. So this newer server, one of these older servers doesn't check. This is my understanding of it. Doesn't necessarily check everything. And this is sort of meant to stop pass the hash and replay attacks and stuff like that. This is the normal Kerberos type attacks that one does. But in this case, is you can get a response back, and what you do is you just sort of basically say, oh no, this message isn't signed, don't worry about it, server. And seeing the server doesn't have all these checks mandatory, it goes and accepts it. Which is rather sort of, sucky, it happens. And it can give you remote code on a box. Once you've got remote code, you're only a couple of Kerberoasts and, what's the, I've forgotten the term, what's the tool? Can't remember the tool that I'm trying to think of. That basically tells you the path to root, DA, and then wham bam, you got DA, you got your access. It reminds me a bit about some of the JWT attacks. And what some of these JWT attacks allowed was JWT, for those who don't know, is some JSON Web Tokens, or sub acronym that's very similar to that. And basically, as a way of sort of providing sort of authentication between servers that might not necessarily have a direct connection to you. You can have an auth server for single sign-on, and then this JWT token can be used on other servers. And because the content is signed, JWT tokens, the idea was that, you can't just sort of copy them or alter the details that are signed, because instead of normal sort of session cookies, the actual session is stored on the server and your cookie is just a random number. But in JWT's case, the actual cookie contains all the sort of authentication and authorization data, but it is signed by the single sign-on or the authorizing server, so the server actually performing the actions is meant to trust it. But there's, unless you've turned all the options on in JWT, sort of on the sort of the server that's doing the work, what can happen is you can change the headers in the JWT token to say, the encryption we're using is none, the signing we're using is none. So you can basically just put in your user X with full admin permissions, and the server will just believe it, because it's not actually checking that it is signed and encrypted in the correct and hashed in the correct way. So it's sort of interesting to see sort of a similar, what I think is a similar attack actually showing up somewhere else. So maybe another, with JWT now, more of the libraries are actually shipping by default with don't allow the none cipher. Maybe only accept the ciphers that you actually use to sign. So in made an agreement amongst your system that we're only going to use this particular method of hashing and signing, and then basically reject all JWTs who don't have that signing. It's a good toasted sandwich. Very good pastrami. Nice pickles. So we were a colleague of mine sort of on Twitter said something a bit funny. It was sort of with these Microsoft systems, you can either have a Microsoft network that works, or you can have a Microsoft network that's secure. And it basically comes down to all the new security features in the Samba and stuff only really work if you've got Windows 10 and Windows Server 2016. You sort of have to run the latest and greatest. You can't have any legacy servers. You've got to upgrade everything. Because as soon as you have one of these older servers or these older desktops, you've sort of got to start turning some of the security options off. And then quite often, even if you then subsequently update all your servers and desktops, no one actually goes back and turns on all the security options inside the domain admin for the group policy. They just update all the servers and the desktops. Don't think to go back and see whether they can actually re-baseline any of the security settings. Well, that's until a pen test company comes through, rips through, and points out that all this could have been stopped had you ticked all these tick boxes in the server to sort of turn off all the legacy Samba related stuff, so we can't access file shares, so an attacker can't, run remote code. And so on like that. So I was also thinking another interesting research idea would be, is there any other systems like the sort of, which is sort of single sign-on, uses some sort of token that is signed and carries data amongst that to sort of provide that their authentication has happened and this user is trusted. I suspect it'd be worth researching some of these other areas and see what else, whether there is that null cipher. Do all the libraries actually require you to have everything in place? Or will some libraries sort of fall back and just work because it's better to have something working than sometimes having something secure, particularly the library people, because open source library, you ship, so the default state, you want it to be works out of the box, support the older version, support the newer version. You don't want to sort of have all the support because you don't have the money to support it. So you do that. So I think that'll be an interesting thing to research. And see what else is out there in some area, because I'm sure there'll be more. And just likewise, there's going to be more and more Microsoft vulnerabilities in Samba, I'm sure. Won't be the first one, nor will it be the last one. And that's me, sort of pretty much finished my sandwich. So make sure you like, subscribe, click the notification bell, follow Bite-Sized InfoSec on Twitter. Also that Patreon page that you can go to, kick a few bucks. The more money, the more lunches I can buy for Bite-Sized InfoSec. Pay me more, I can actually start travelling to more places more regularly, so you can see sort of cafes and food from around the world while you listen to some Bite-Sized InfoSec snippets. So that's me. Thank you for listening. I'll see you all on the next episode.